I'm going to talk today about enterprise blockchains. So for those of you who don't know what an enterprise blockchain is, it essentially means a blockchain with some notion of permissioning, where it's not open to everybody to do everything, but rather certain parties have certain roles, and maybe not everybody can connect, and not everybody can transact, and not everybody can build blocks. So it's a kind of different world from the world of cryptocurrency in terms of applications, but in terms of the technology, it has a great deal in common with the kind of cryptocurrency blockchains that you're all familiar with. What I'm going to talk about specifically is 10 enterprise blockchains that actually work. And by that, what I mean is 10 networks built on our platform that are in production, solving a real problem, providing real value. The reason this is kind of important is that we've heard so much in the past few years about PoCs and pilots and enterprise blockchains. It's important to kind of see which projects actually make it to production, and we're going to talk about their characteristics at the end and some lessons that can be learned. So a little bit, first of all, about Multichain. Multichain is a platform for building blockchain applications, specifically permissioned or enterprise blockchain applications. So just like when you build a regular centralized application, you'll quite often be building that on top of a database platform like SQL Server or MySQL. Multichain does the same thing for blockchain applications. It's a piece of software that all the participants in the network install, and the application sits on top of that software and uses the API that Multichain provides in order to provide the application's functionality. We focus very much on making it as easy and as fast as possible to build and get up and running on top of the platform. One of the philosophy guidelines we believe is that you shouldn't have to program your blockchain if you don't want to. So our Multichain does support something called smart filters, which are rather like smart contracts, which allow you to define all kinds of custom logic for your application. You don't have to. There's a huge amount of functionality built into the platform that solves most of the things that most enterprise blockchains want to do without you having to write your own code. It runs very fast, up to 2,000 transactions per second on the right hardware. It's very, very stable, and our users are very happy with it, and they build on it a great deal. We don't do projects for end customers, so when I say that we have 10 enterprise blockchains that actually work, what I mean is that our partners have built 10 enterprise blockchains that are in production. We focus on developing the core platform, and we've partnered with more than 100 companies who use Multichain to build solutions for their customers, and in some cases for their own proprietary products. We're there behind the scenes to provide support, both for the development process and also once things move into production. A little bit about the history of the product. So relatively speaking, we're real old-timers in the space. We started developing Multichain in December 2014, and the first alpha came out in June 2015. This is before the time when enterprise blockchains became very popular and everybody was talking about them. 1.0 went into production in the summer of 2017, and almost all of the projects I'm going to talk about today are up and running in production on version 1.0 of Multichain. Version 2.0 of Multichain was released a couple of months ago in March 2019. This adds a great deal of new functionality to the platform. For example, smart filters, which allow you to define custom logic for validating transactions and validating data. Deep support for off-chain data, meaning that when you publish data to a blockchain, Multichain can take care of delivering that data across the network in a decentralized way and only putting a hash of the data on the blockchain. And also a lot of functionality to make the kind of data you can put in a blockchain very rich, supports for JSON, support for text, et cetera, et cetera. We're now in the process of developing a number of enterprise versions of the software, which until now Multichain has been open source. Multichain has been what's called 2.0 community. We're now developing enterprise versions of the software. These provide the same functionality as 2.0 community, but a lot of additional functionality that are of particular interest to enterprises. Words like confidentiality, scalability, compliance, regulation, integration, all these things that enterprises find very important. But 2.0 enterprise is going to be backwards compatible with 2.0 community, and you'll also be able to mix both types of nodes on a single network. So you can have some participants in the network on community and some on enterprise. So before I start talking about the projects themselves, I just need to give a caveat, which is that for some of these projects, we cannot tell you absolutely everything about them. There are some projects that we can tell you nothing about, and they're not included in the presentation. There are some projects that have the identities of certain participants kept secret, because that's the way they want it, and we have signed I don't know how many hundreds of NDAs over the last few years with our partners, and we of course have to respect those NDAs. But we're telling you what we can. So, first project. This has been implemented and is now in production, implemented by SAP in Germany. In the US, there's new regulation coming in which requires verification of pharmaceuticals after they are returned from their customer. So a customer buys some pharmaceuticals, let's say a hospital. The customer then ends up not using those pharmaceuticals and they return them back to the wholesaler. how do we know that those pharmaceuticals returned to the wholesaler or that box of pharmaceuticals is actually original product? Well, the answer is we need to create a database or a registry of pharmaceuticals that are shipped. Then every box that comes back to a wholesaler distributor can then be verified against that registry. So SAP have got this up and running. They've signed on 10 major US drug manufacturers and 2 wholesalers, and they're still negotiating with more parties. I can't tell you names, but if I could tell you the names, you'd have heard of many of these names. What they've built is a network where each manufacturer is running a node, and each of the wholesaler also has a node that belongs to them. And every time a drug is shipped, that information is summarized about the drug on a label barcode that's put on the box, and then a hash of that barcode is put onto the blockchain. And then when the box comes back to the wholesaler, they can scan that barcode, hash it, and then compare the hash against the hash on the original hash that was put in the blockchain in order to verify that that is original product. This is our high-scale project that we have in production. It's been tested to run to 1.5 billion pieces of data per year. So that's a relatively large-scale enterprise blockchain. It's running at about 10% of that now, and as they're bringing more partners live, if they're bringing more of their customers on live, that's going to increase. Why are they using a blockchain in this case? And that is the question you always need to ask. In this case, they're using a blockchain because there is no central US government entity which is responsible for creating this database. In the EU there is, and in the US there isn't. So this database of shipped pharmaceuticals, where's it going to sit? There isn't an easy answer to that question. None of the individual pharmaceutical companies are willing for the other pharmaceutical companies to be responsible for this database, and they don't have the regulatory ability to just give the job to SAP to run in a centralized kind of way. So instead, a decentralized solution was required, and that's what they've got up and running. Project number 2, this was developed by Accenture in Europe. So there are many cases where publicly financed projects in developing countries are ultimately funded by entities in the developed world. This is an example for Germany. And all of these projects have a large number of stages, like tendering, like procurement, like managing the contracts, like keeping track of payments. And what you have essentially for each of these projects is a series of events. And the participants in these networks, in these projects, have to keep track of those events. Now, it's not politically comfortable to centralize that database of tracked events in any particular place. You could centralize it in the bank that was responsible for funding the project, but that's not really very good for the developing country because they don't feel very comfortable with that. You could centralize the database in the developing country, but that's not very good for the people funding the project. There are also additional partner countries who are helping to fund the project, and I cannot mention their identities. You can't put the database there because no one else is comfortable with it. So we have a situation here where we need to keep track of every event relating to a project, but there's no easy central place to put that database. And that, of course, is an example where a blockchain is useful. So this is a blockchain up and running in production, used to track funds that come from developed countries to fund projects in developing countries. It's not such a high-scale project. It's not such a high-scale blockchain. We're talking about 300 projects maximum that will go on a single blockchain, and each project has a maximum of around 5,000 events. So it's 1 or 2 million events in total on a particular blockchain, which isn't very much compared to what we saw in the previous project, but it's absolutely crucial that these events are entered into the blockchain, that there's protection against tampering of those events, and that every participant in these network agrees what happened and when. When I was preparing the slide for this one, my 8-year-old son finally found what I was doing interesting, because he saw the logo of Real Madrid and the logo of Arsenal, both very famous football teams in Europe, and he asked me what on earth I was doing with these clubs. So there is an industry called sports collectibles. Right? When I was growing up, it was stickers, football stickers, or soccer stickers, as you'd call them here. But of course, this industry is moving into the 21st century. Now you can have digital collectibles, where essentially you have an app on your mobile device which enables you to collect stickers or other cards which relate to particular players of teams and particular events in those teams' lives. Now, the issue here is that fans of each sport club want to have confidence that the stickers or the cards that they're collecting are genuinely issued by that sport club that they're following. On the other hand, we also want a system whereby fans of different sport clubs can exchange cards with each other. So that if I have 2 of a particular card, or if I have a card I don't particularly like, I can exchange that in an atomic, safe way with somebody who has a card for a different sports club. So we have an example here of the need for a unified database which is used by all of these sports clubs, but we also need to have each of the club maintaining meaningful control over their actions in that database. So again, this is a good use case for a blockchain. This project was developed by PwC and Fantastic in Europe. It released a couple of months ago. It has so far 15,000 users, and about 250,000 collectibles have been issued onto the blockchain so far. Project number 4. This was built by a company called DeepSure, who I can see in the audience. Hey, guys. So the Metro Group is the world's 4th largest retailer. And as a large retailer, they collect a huge amount of point-of-sale information. This is essentially every time a transaction takes place at the till and the customer pays, something is recorded. They need to archive this information, and in order to be compliant, they need to archive this in a particularly safe way. So how do they do that without becoming dependent on some individual specific hardware provider or some individual specific cloud provider? The answer is that DeepShore built a system that enabled Metro to store their data across multiple different cloud providers. And what they have is a blockchain which is being used to keep track of the metadata of that information and also of a hash of each piece of that information. So there's a blockchain network running inside the Metro Group in different departments, in different geographies. Onto that blockchain, they're putting the metadata and they're putting the hashes of the point-of-sale data. And the data itself is being stored in all sorts of different places and all sorts of different cloud networks. We're talking about a reasonably large scale here, 9 million data sets per day. And those data sets represent over 100 megabyte of underlying information that is stored in the cloud. But it's the hashes and the metadata of that storage which is going in the blockchain. Project number 5. This is a project for one of the state governments in India. I cannot say which one. It's an electronic health record project. So electronic health records enable people to seek healthcare in many different healthcare providers within the state and not having to bring their own information with them, but instead each of these healthcare providers has access to that person's information in a logically sense in a centralized place. But the problem with actually physically centralizing these healthcare records in this Indian state is that number one, internet connectivity comes and goes. So if you lose internet connectivity, if you're in a hospital in one city and the database is another city, well, you can't get access to your data. And number two, there is a desire to prevent corruption of that data or modification of that data. So a blockchain has been built to store these healthcare records. There will be nodes distributed in multiple cities across the state. The information that goes in the blockchain is partially anonymized and partially non-anonymized, so, or I should say obscured. So the personally identifying information of individuals, which includes their date of birth and their name, is hashed in order to create something that identifies the record. And then the medical information itself is put into the blockchain in clear text. And in the future, this is going to be expanded to also store images. You can store very large amounts of data in multichain, so that's not a problem. 6. Now, when I first heard about this project, I was a little bit surprised that cows could have something to do with the blockchain, but actually, it's a brilliant project. So in developing countries, and again, unfortunately, I can't say which one, but there's one particular developing country which is already live, there is an issue. Farmers own cows. Cows are worth money, and you can get a loan against something which is worth money. You can use your cow as collateral. But the information processes required in order for the people lending money to know that that farmer owns the cow is broken. It didn't exist. So they need to create a system whereby a record is kept of which farmer owns which cow, then which cows have been immunized, because a non-immunized cow isn't worth as much because it can get a disease, which immunized cows have been insured, because a non-insured cow is not worth as much as an insured one, and then which loans have been made against these cows to prevent a farmer using their cow as collateral with 2 different financial institutions. So there's a tamper-resistant NFC tag embedded in the cow's ear, and you have on this network, you have government ministries, you have insurance companies, you have financial institutions. They're all participating in this network, and the goal of this network is to create a unified record of cow immunization, insurance, and use as collateral. Why couldn't they centralize it? Because this is a developing country where the governance is challenging, and they would not be comfortable putting all of that information in any single individual place. All of the participants in this network want to maintain meaningful control over this database. They're not willing for it to just sit somewhere else under someone else's system. So by using a blockchain, they all share this meaningful control, and none of them are able to corrupt or modify the data put in by the others. This is now live with hundreds of thousands of farmers in this particular country. Number 7, environmental air quality. So this is a project in Austria developed by Baumann. There are different types of environmental information that are stored in the system. There is ozone measurements, there is weather measurements, and there's measurements of radiation. The goal of this blockchain is primarily just to aggregate and distribute the data. So you have nodes belonging to each of the organizations that's responsible for sourcing each of these types of data. They're all writing information into the blockchain. You then have other nodes that are only reading information, schools and libraries, in order to provide access to that information for school students and for research. And the goal of the blockchain here is primarily just to act as a decentralized data distribution mechanism, with a bonus of providing some tamper-resistant, with the bonus of us knowing that nobody can modify or mess with that data once it's put into the blockchain. Now, what's interesting about this project is although it's only 1 million records per year, approximately, or a little bit more, it's actually quite a lot of raw data, because we're talking about measurement data. So they're putting 3 gigabytes of data in the blockchain every single year. Now, people often talk about how blockchains are inefficient and hard to scale because they're replicating this data so many times. And in a theoretical sense, that's true. But if you think about a blockchain that's putting in 3 gigabytes of data in a year, well, after a century, that's 300 gigabytes of data. And that means each node has to have a very, very cheap and easy to find consumer hard drive in it in order to store all of this information. So it's not really a big problem today to have large amounts of data replicated multiple times because hard disk drive storage is so cheap. Number 8. This is the TAG group based in the Philippines. So the Philippines has no centralized credit scoring organization. And there's a desire here to create such an institution, but there is no actual physical or legal institution in which this credit scoring database can be built. So instead it's been built on a blockchain. The members of the blockchain are several financial institutions in the Philippines. And what they're doing is they're putting information on the blockchain about loans that are given to individuals and also about whether or not those loans have been repaid. And that information can then be seen and shared between the multiple participants in the network. It's a relatively small network right now, writing about 100 records per day, but expected to scale to around 10,000 records or 10,000 events per day. Again, as we've seen in previous cases, we have a mixture here of personally identifying information that is hashed in order to not be visible to all the participants in the network, and some information that is entered into the network in clear text. We've all heard about food verification projects on the blockchain, so this is one in production, albeit at a small volume of transactions right now. So the purpose here is to have a place where every single action that takes place to a particular food item on its way from production to consumption is recorded in the blockchain, and then there's a label on the item which consumers can scan in order to read that information off the blockchain in order to see the full history of that item. So the purpose here is simply to create a system where no individual party is in charge of this database. It was developed by Worldline together with Bureau Veritas, which is a very large organization that has offices all over the world which does food verification. And the purpose here is to enable the people consuming that food in order to verify where that food came from and what happened to that food on the way to their mouths. Last project, ILS Blockchain. ILS stands for Insurance-Linked Securities. So if you want to issue a financial asset, such as an insurance-linked security, you have to have some kind of clearinghouse that holds it. Well, first I should tell you what is an insurance-linked security. Insurance-linked security is the following. I lend money effectively, I purchase a bond. So long as a particular catastrophe doesn't happen, I get back the value of my bond plus some interest, which is essentially the insurance premium paid by the counterparty. But if a catastrophe happens, if the ship sinks, then I lose some or all or most of the value of my bond, and that's providing the insurance cover for the counterparty. So it's a way of taking insurance policies that we're all familiar with and taking the role of the insurance company and making it something that can be purchased and held by multiple people simultaneously. So if you have a security of this nature and you want to make it possible for people to hold that security and to transact in that security, generally speaking, you need some kind of custodian or some kind of clearinghouse which is going to be responsible for holding that security and keeping track of who owns it and how it's changed hands. The problem with this is that that particular entity is heavily regulated and is rather expensive, and the service that they provide will start at, say, $100,000 or $200,000 per year per security. So if you're issuing a small bond, and we're talking here about bonds in the $10 to $15 million range, that becomes a rather large percentage of the total value of the bond, and an even larger percentage of the total profit that the bondholder is going to make, even if the catastrophe doesn't happen. So Solid and Ray, or Solid and Partners, had to find another way to issue these insurance-linked securities and to enable people to hold them and transact in them. And what they've done is they've created a blockchain built on Multichain called ILS Blockchain, which enables the people holding these securities to have direct custody of those securities and to also transact with each other in a direct peer-to-peer way, whether they're just sending it from one party to another or whether they're performing an exchange of these two securities. And by having this decentralized database, Solid and Partners have been able to convince the regulator that they are not a standard custodian, they are not a standard clearinghouse, and they don't need to be subject to the same kind of regulation as a normal one would be. And as a result, that massively reduced costs. So by putting these assets on a blockchain rather than holding them in a traditional way, the cost of the whole process becomes much, much lower. So those are 10 projects in production, built on Multichain, that are running today live. And I want to talk now with the remaining time about some of the lessons I think we can learn from looking at what's in production. Because as many of you may know, there's been, and I can talk about our own platform, hundreds if not thousands of PoCs have been built on our platform to try out all sorts of weird and wonderful and sometimes very good ideas about what you can do on a permission blockchain or an enterprise blockchain. So what can we learn by looking at those projects that have actually made it to production? So, number one, every single one of these projects is new. They are all new systems, new networks that solve a particular problem. They're not coming to replace an existing centralized network. They're new. Now, what does this mean? It means that if you think about replacing an existing network, that's really a very, very tall order. Number one, if something's working, people are generally not going to want to rip it up and move to something else. Number two, it's very costly, right? You're going to spend all this money building a system when you already have a system that's up and running and working. And number three, if you have a centralized network that's up and running, well, that generally means you have a central counterparty that everybody is already proven to be comfortable working with. And as I'll talk about in a minute, if you have a centralized counterparty for a database or for a network, then there's not really much point decentralizing it because you don't have any need to. Lesson number two, you need, in every case where you want to actually put a permission blockchain in production, or I should say even a non-permission blockchain, you need a strong motivation to decentralize. If you're comfortable centralizing, if you have a central party that all of the participants in the network are happy to use, there is no point using a blockchain. Blockchains are slower, they're less scalable, they're less stable, not less stable, I should say, less mature, they're more complex than traditional centralized databases. So you should only use a blockchain if you have a very strong reason to. And if we look at these projects, what we see is the standard motivations that come up are, number one, commercial concerns. The participants in the network aren't comfortable handing commercial control of their database to some other party. They have the need to have commercial control for themselves. But they still want everybody to have a unified view of the data. Number two, regulatory requirements. The regulator says you cannot centralize this, or the regulator says if you do centralize this, it's going to cost you a lot more. And number three, political risks. When you have a political reason why you don't have any comfortable place to put your centralized database. Now, if we think about Bitcoin, which is where all this conversation kind of started, Bitcoin, with all of its technical wonder, is ultimately an answer to people's perception of political risk. Right? We decentralized this currency, this decentralized database, because people want something that cannot be easily shut down from a single place. And so that logic behind using a blockchain, and Bitcoin is, of course, far less efficient than PayPal, but that logic behind using a blockchain applies whether you have a public blockchain or whether you have a permission blockchain. It's the same logic. You need to have a strong reason not to centralize your network. Lesson number three. The majority of blockchain use cases, at least that we see, are not to do with tokens, they're not to do with assets, they're not to do with something financial moving hands. A few are, but the majority of them are about data. They're about having a way to store data in a decentralized fashion. Now, any kind of data store, whether it's a file system or a centralized database, can be put on a blockchain, right? You can use a blockchain as a way to store your data. It doesn't always make sense to do so, but you can always put your data on a blockchain. And if you think about the universe of applications in the world that are built on computer systems, a minority of them are related to financial assets. Most of them are dealing with data in some other way, shape, or form. And so what we're seeing in terms of what's going on to production on our platform is, yes, we have some use cases that are related to assets, but the majority of them are related to data itself. Now, if the purpose of your blockchain is storing and retrieving data, smart contracts are just the wrong model, right? You don't want a computation to have to be executed every time you embed a piece of information in a database. You may want a computation in some cases when you're reading the data. You may want some validation logic in some cases, but you don't want everything to be a smart contract. You want to actually have data that goes in as is straight to the blockchain. You don't want what you submit to the blockchain to be a transaction that triggers some logic that updates some database. You want to write to the database directly. And if you want a data-driven use case on a blockchain, what you want to focus on are things like scale, speed, how can you index that data, how quickly can you retrieve that data. And it's not related to things changing hands from one party to another. Lesson number 4. So if you look at most of these use cases, we could say they're not necessarily transformative. You know, one or two of them may be enabling people to collateralize their cows in a developing country. Well, that's quite socially transformative. But the majority of these use cases are not transformative in any economic or social way. And we could imagine how they might be able to be built on a centralized database, even if that wasn't suitable in these particular cases. So why was a blockchain used? And the answer was, quite simply, it was the most appropriate tool for the job. There are many different patterns of enterprise integration. We have messaging, we have centralized databases, we have APIs, and now we have a new one, and that's a blockchain. And a blockchain has particular characteristics which make it suitable for particular use cases. And what a blockchain gives you, apart from decentralization, is gives you a sense of greater robustness for your data, that it's much harder for that data to be lost, and also a greater sense of tamper resistance, that it's much harder for that data to be modified. And so if you have a data-driven use case where these things are benefits, and you don't have to do 20,000 transactions a second, then a blockchain can just be an incremental advantage over some other way of working, rather than necessarily something transformative. The other interesting thing about using a blockchain, and we see this sometimes, is that the moment you use a centralized database, you know it's going to be very hard to move that somewhere else, right? If you have your data in a centralized database, and you decide in 3 years' time you want to move that database to a different organization, it means a long migration process. It means shutting down the database, having some offline time in your system, and then migrating the data and bringing it up in a new database. And that's quite a daunting prospect. Whereas if you use a blockchain, you preserve for yourself complete flexibility in the future. You can add nodes. Those nodes asynchronously will update themselves with the data in the network, and then once they're up and running, you can start using them. You can remove those. You can change the governance model over time. You can decide to transition the database from one place to another. As soon as you're using a blockchain, you know you have much more flexibility in terms of migration in future than you would have in a traditional centralized database. And lastly, and maybe this is obvious to everyone here, it's still really incredibly early in the enterprise blockchain space. So we've been in this space now for almost 5 years. We're seeing now a significant number of projects move to production, but it's taken a long time to get there. We see that most of our partners are actually running really basic stress tests against our platform just to see that it actually works, and it doesn't break down, and it doesn't crash, and that it scales, because people are still getting used to this thing. It's pretty normal for it to take 2 years from the moment when somebody starts engaging with us and with our platform to when they actually move to production. So people are very cautious, they're very slow. We also see that sometimes the people who are participants in a network aren't yet confident enough to run their own nodes, so they're asking someone else to run their nodes for them. And if you ask me what I think is going to happen in this field, I think enterprise blockchains as a pattern of inter-organizational integration will probably take 10, and if I'm more realistic, 20 years till they reach some kind of saturation, until we reach the point where most of the times that a blockchain would make sense, a blockchain is actually applied. So I'm going to stop now, and I'll be happy to take any questions for a few minutes if anyone has one.
Which kind of consensus algorithm is used to coordinate?
So the short answer is proof of authority. So if you have a permissioned blockchain, you have a number of parties that are given the collective responsibility of validating the network and building the blocks in that network. So it's not based on proof of work or proof of stake or anything like that.
It's a federated.
Like a federation, yeah. Yeah, exactly. It's a variation on round robin, yeah. Any other questions? Yeah, got a question here?
Hi. Thank you for the lecture, first of all. I've seen that you made some of the use cases you mentioned have serious need for decentralization. But the question is, has there been any analysis done, and how much, as you mentioned, like it's more expensive to use blockchain, decentralized services, so has there been any attempt to realize how much more expensive it was other than using a centralized service, and then seeing like for what use case will go which way?
Yeah, so it's really interesting because there's two different types of costs. You've got technical cost, which is like bandwidth, CPU, memory, disk, and then you've got like organizational cost of multiple nodes being run. So the technical cost, while it exists, is close to negligible in reality, right? And I think that's why we're seeing this now rather than 20 years ago, because the cost of, Multichain runs very well on a $5 a month node that you can get from, any cloud provider. So the actual technical cost of running a blockchain node, unless you have a very, very high scale application, is close to zero. It's not really a major concern in most cases. Where the cost may come in more is when you think about the fact that instead of having a single system that a single organization is responsible for, you have multiple nodes effectively. Each node has to be managed or monitored or watched or checked. And that could be a more meaningful cost that people look at. But as I mentioned, you only really use a blockchain, or you should only really use a blockchain when you have to. So when your alternative to using a blockchain is just not being able to digitize your system at all. And in that case, you're not looking at a cost of blockchain versus centralized, you're looking at a cost of blockchain digital versus a non-digital process. And that obviously changes the calculations. Any more questions? Yeah, question. Do we see consortia using tokens? So you can configure multi-chain to have a native currency on a blockchain, which I think maybe that's what you mean by a token, because some of these things were assets that were issued on top of the blockchain, but I think you mean like some kind of native currency of the process. You can configure multi-chain to do that. We've not seen anyone in production using that. The only reason that there is to use some kind of native currency or native token on a permission blockchain is if you want to have a mechanism for preventing transaction spam. If you want to prevent people spewing too many transactions into the system and there not being any cost to them whatsoever. So that is relevant in a case where you might have a permission blockchain where, say, the validation is permissioned, but the transacting isn't open to the whole world. But in all of the cases I'm talking about so far, we're talking about networks which are actually closed in terms of participation. And then you just don't need a native token at all, because there's no concern about transaction spam. Somebody knows who everybody is if they're putting too many transactions in.
I was thinking more about incentivizing behavior.
So the incentive of using a permission blockchain is kind of the incentive, similar to the incentive of if you have a company running your own mail server. Like, why would you run an email server in your company? And the answer is because you want to receive and send emails. So it's a little bit like that. It's like people who want to use a blockchain, they're completely incentivized to use their node because they need the functionality it provides, and they don't need any other further financial incentive. Any more? Yes, question over here, yeah. Behind, yeah.
On one of the learnings, you alluded to the fact that the smart contracts should not be used for data. Could you just double click into it? What exactly you meant by, not to apply smart contracts on the data?
So the smart contract paradigm is a paradigm where you have code embedded in a blockchain. And every transaction that is sent to that blockchain is triggering that code in order to do something. In many cases, it will be triggering that code in order to modify some entry in the underlying ledger that blockchain is managing. So that model whereby every event on the blockchain is a trigger for some code that then does some secondary thing is very inefficient when all you're trying to do with your event on the blockchain is insert a piece of data. If you just want to insert a piece of data, you want to literally just add the data to the blockchain. You don't want to have to go through this additional smart contracting process where you have some kind of piece of code which is sitting in the middle and intermediating in that process. Any last questions? Good. Well, thank you very much for listening. Come see us in booth 116. And most importantly, we have a very large number of M&Ms that need to be eaten. So come to our booth and have some M&Ms on us. Thank you.